Right, class, it's your Professor McCringleberry and my lovely assistant, Karen.
Hey,
Hey, Karen, what day is it today?
it's Tuesday, isn't it?
It is. Let's do a little chemistry. Now, today, we're going to be learning how we can use an oxidation number to write a simple molecular formula. Now, in order to do this, we need to know the Lewis dot structure. Wait, I've got a little E there. And the number of valence electrons an atom has. Now, when we jump over to our periodic table, we know a couple things. All the elements here in group 1 have one valence electron. They are also going to want to lose that little bugger. And when they lose that little bugger, they're going to form a positive 1 ion. Same goes with group 2. Except for now they're going to want to have 2 electrons lost. 3, same thing with 3, and so forth. Now, we're going to forget these little guys, because they just wreck everything and make it all complicated. But group 5 now, instead of losing electrons, they're going to want to gain a couple. So group 5 wants to gain 1, 2, 3. Oh, bloody hell, I messed that up. Righteous. They're going to want to gain 3 more electrons in order to be just like their good old buddy neon. Okay, so they're going to actually form a -3 ion. Oxygen in group 6 is going to form a -2. That is the opposite of a 2. That's a 0. Okay, and then finally in group 7 they're going to want to gain only 1 electron, and then they get that noble gas configuration. And we know that atoms do this through bonding. Now, what actually happens and what the heck is an oxidation number? So if we look at all the elements in group 1, they have an oxidation number of 1+, meaning they are something like sodium with 1 valence electron that they then transfer to a non-metal, giving them a formal positive charge. That is their oxidation number. Now, chlorine on the other hand is the opposite of that. It's going to gain an electron and it's going to have a -1 charge. What do you think of that, Karen?
That's fascinating.
Oh, you betcha it is. Now, how can we use these little boogers to write us a good old-fashioned molecular formula? Let's jump to the next page. Now, say we got magnesium and we want to bond it with oxygen. Now, magnesium is in group 2, so we know magnesium is going to want to lose 2 electrons, which gives it, yep, that's right, a 2+ oxidation number. Now, oxygen, on the other hand, is going to gain 2 electrons, and it's going to have a 2- charge. Now, what we use is we use a little term down under we like to call crisscross applesauce.
That's fascinating.
You betcha it is. Now, we just crisscross that number and we drag it down there, and we drag this one down over here to oxygen, and we end up with something like Mg2O2. But you'll be like, Mr. McCringleberry, that just looks ridiculous. And I'll be like, you're right, because it's a little bit redundant. So when using the crisscross applesauce method, we reduce these to the lowest common denominator. And so we end up with magnesium oxide. And when we draw the Lewis dot structure, we can see why. Magnesium has its 2 electrons. Oxygen has 6. And when those 2 electrons get transferred over to oxygen, it's in a nice, clear 1-to-1 ratio. Now, here's what happens though. Well, we don't want sulfur. It's bloody ridiculous. Let's get a little more magnesium in our lives. What if we had something like magnesium fluoride? Okay, again, magnesium we know has a +2 oxidation number. Lost my train of thought there. And fluorine has a -1 oxidation number. So this creates a little bit of a problem. We can see this with the Lewis dot structure. So fluorine only wants to gain 1 more electron, but magnesium has 2, so we can only transfer 1 to him. So what do? Well, we need another fluorine to give that other electron to. So how can we use the oxidation number and avoid all them headaches? You can simply apply the crisscross applesauce method as we talked about earlier, and we can see now, wow, we have magnesium and 2 fluorines. So we get MgF2, not Fu.
That was a good one, Professor.
You can apply this method all the time when you're doing chemistry with your friends. Good eye.